Okay, I started doing the notes today, and I was like, this is going to be way too hard. So we're going to go backwards, and this is what I want you to do. I want to take you to take the note sheet that I gave you and just set it aside and leave it in your binder. And I just want you to take out a blank sheet of notebook paper while you're doing these notes. Okay, and we're going to go back and we're going to review some from sixth grade because I just think that's too much to start today. So what's going to happen is I'm looking back at the sixth grade book in chapter 8 where you learned about equations last year, and we're just going to go back and review a little bit. Okay, so if I have a problem such as x plus 5 equals 8, they want to know, find the value of x such that the left side balances the right side. Okay, well, in the first place, when you're dealing with an equation, it's cut in half at the equal sign. The left side is on the left of the equal sign, the right is on the right side of the equal sign. So what we need to do is we need to figure out what value we can plug in for x to get 8 on both sides of that equal sign. Okay, and I know you guys are bright. Now you're like, oh, we shouldn't have gone back, but you're going to tell me 3 plus 5 equals 8. That way we have 8 on the left and we have 8 on the right, and you would be absolutely correct. Okay, same thing. What if I have x minus 7 equals 3? So now I need to, again, draw a line through my equal sign because it cuts my equation in half. We need to figure out what number take away 7 equals 3. And you're going to tell me 10 minus 7 equals 3. And again, we're equal because we have 3 on both sides of our equal sign. Now, how would we do that not just guessing? What if it was a problem that we didn't know off the top of my head? What if it was negative or x minus 12 equals negative 7? Many of you can't just look at that and come up with the answer. So we need a way that works every single time. So this is what happens. So I'm going to skip this one and go back to the x plus 5 for a minute. X plus 5 equals 8. When you're dealing with the equations, you deal with inverse operation. Inverse means opposite. So if you're dealing with an addition problem, your addition and subtraction are opposites. Multiplication and division are opposites. Okay, so if I have an equation that contains a plus or an addition sign, the whole point of any equation is to get the variable alone. You want to get that x alone so you can figure out what it equals. Okay, so if I want to get the x alone in this problem right here, I need to get rid of whatever's on the same side of the equal sign as the x, which in this case is a positive 5. A positive or a plus 5. The opposite of a positive or a plus we just said is a negative. So to get rid of positive 5, you need to do the opposite, which is negative 5. Now, we learn in math that pretty much when you do something to one side, you do it to the numerator, you have to do it to the denominator, everything else. So if I subtract 5 from the left, I need to do the exact same thing on the right. So if you look, I put minus 5 on both sides of my equal sign. That's why I draw the line there, so I keep myself organized. Positive 5, negative 5 cancels each other out, and on the left, I'm just left with x. I bring down my equal sign, and 8 minus 5 is 3. Now, the nice thing about equations is you can never get them wrong because you can take your original problem, x plus 5 equals 8, and you can substitute that value in to make sure that you did it correctly. 3 plus 5 equals 8. 8 equals 8, so we did it right. Okay, so let's go back up here. This was x minus 7 equals 3. X minus 7 equals 3. Okay, so I'm going to draw some lines here. So again, we're going to draw a line through our equal sign. All right, I want to get the variable x alone, so I need to get rid of a negative or a minus 7. The opposite of a negative or a minus is a plus, so we're going to add 7 to both sides. Because remember, whatever we do to one side, we have to do the other. Take away 7, add 7, cancels each other out, so I'm left with x equals 10. And again, x minus 7 equals 3. Plug in that 10 for x. 10 minus 7 equals 3. So we did it correctly. We checked our work. All right, now, let's go back. I'm going to scroll all the way down, and let's try x. Let's do it down here. We have more space. X minus 12 equals negative 7. First thing, draw the line through your equal sign, circle your variable. Okay, we have a negative 12 that's on the same side of the equal sign as the x that we need to remove. The opposite of a negative or a minus 12 is plus or positive 12. And again, whatever we do to one side, we have to do to the other. Okay, negative 12, positive 12 cancel out. Now we have to be careful with our signs. I have negative 7 plus 12. Okay? These are different signs, so we need to subtract. 12 minus 7 is 5, and we keep the sign of the larger number, which is positive. Okay, so let's go back and make sure that 5 works. So this is going to say x minus 12 equals negative 7. We're going to plug in 5. 5 minus 12 equals negative 7. Let's see if that works. We're going to do keep, change, change. That's going to give me negative 7 equals negative 7. So therefore we did it correctly. Okay, so that's for addition and subtraction. Now, if we have multiplication and division, we're going to get the same thing. So let's say negative 2m equals 14. Draw the line through your equal sign, circle your variable. We need to undo multiplication. The opposite of multiplication is division. So we're going to divide both sides by the term that's with the variable, which in this case is a negative 2. Negative 2 and negative 2 cancel out. So we get m equals 14 divided by 2 is 7. Odd number of negatives, so your answer is negative 7. Okay, same thing works if we have division. Let me scroll this up. Okay, so if I have 1/5 x equals 4, okay, we need to get the x alone. So to undo multiplication, we divide, but the trick here is, remember, we don't divide fractions, we multiply by the reciprocal, we flip it. The reciprocal of 1/5 is 5/1. So those are going to cancel out. Got to multiply this side by 5/1, so x equals 20. Okay, so those are one-step equations. So I'm going to go to the next page, and I'm going to give you a couple that I want you to try on your own. Okay, so number 1. r plus 4 equals 12. Number 2, p plus 6 equals negative 13. Number 3, negative 3x equals 21. So take a second and go ahead and try those. Okay, so I worked these 3 out. So here is number 1 right here. R plus 4 equals 12. You're going to subtract 4 from both sides, and you get 12 minus 4 is 8, so R equals 8. What I did here is this is a check. This is just our check to make sure we didn't make a mistake. We take our answer 8, plug it into the equation, R plus 4 equals 12, to make sure that it's a solution, that it works. 8 plus 4 equals 12, so we did that one correctly. Here's number 2, p plus 6 equals negative 13. I circle my variable p, which is what I want to get alone. I subtract 6 from both sides. Those two cancel out, so I get negative 13 minus 6. Negative 13 minus 6, remember, keep, change, change, so you're going to get negative 19, so I get p equals negative 19. Again, here's my work. Negative 19 plus 6 equals negative 13, and we did it correctly again. Number 3, negative 3x equals 21. Again, want to get our variable alone, which is x. Undo multiplication with division. 21 divided by 3 is, this should be negative 7. Okay, so we have negative 3 times negative 7 equals positive 21, because 2 negatives when you multiply and divide make a positive. Okay, so we are going to stop there today, and I am going to, that's what we'll go over tomorrow in class, and then we'll move on Friday to the 4.1, 4.2 notes. So have a good night.